All right, everyone, there's this problem right here. There's a lot of problems that are similar to it. Okay, so I want to work through this one, and there'll be a couple other problems coming on a video that are extremely similar. Box A with a mass of 20 kilograms and box B with a mass of 5 kilograms are in contact on a horizontal frictionless surface. A horizontal force of 15 newtons is applied to A. What force does B apply to A? Okay, now there's no friction here. If there's friction, it's going to be a very different process. So I might come back and rework this with friction, just so that we know how friction applies. But since there's no friction, it's going to be a simpler problem. First thing I need to do is find the acceleration of the two boxes. Now there's numerous ways to do this. The meaner people would work each box separately and come up with two equations with two unknowns. We don't have to do that. What we can do is combine the two boxes. So we can work with a 25 kilogram box, has a force of 50 newtons applied to it. Okay, and if I go draw my free body, we have mg going down, which is 25 times 9.8. And that comes out to, let me get my calculator, validating the OS. Why does TI make these calculators that do that? 25 times 9.8. There's a couple of models of TI calculators that like to delay you every time you turn them on. They have to go through this boot up routine. Whereas if you get one of these, it's just on. I mean, it's what calculators are supposed to do. Okay? Anyhow, that's 245. Going up, we have a normal force. Now, there is no friction, so I don't have to do anything with that. But we do have an acceleration this way. Okay? Now, I'm going to go through the usual routine. The first step is a free body. Second step is components. Now, this problem right here, there are no angles to it, so there's no components to deal with. So that's a good thing. Next step is sum of the forces in the y. So I'm going to come up here and do sum of the forces in the y. And that'll be ma equals up minus down. It's not accelerating up, so 0 equals normal minus 245. So my normal force equals 245. Now there's no friction, so I get to skip the friction step, which would be friction equals mu times normal. Okay? I get to go straight to sum of the forces in the x. That's ma equals right minus left. Now, I don't know the acceleration, but I know the mass, so 25a, and that's to the right, so that's positive, equals to the right 50, and there's nothing to the left. So I find a is 2 meters per second squared. Okay? Now what I'm going to do from here is I'm going to draw a free body of one of the two boxes. It doesn't matter which one from here. Okay? I'll probably draw box B because it has fewer forces on it. Now box B has a mass of 5 kilograms, so mg will be 5 times 9.8, and that's 49 newtons. Going up, I have a normal force. Okay? Going to the right, we have the force between the boxes. So I'm going to just put force of box A here. And we are accelerating to the right, and that acceleration is what we just found a minute ago. My acceleration is 2 meters per second squared. So I can go through the same routine. Free body, next step, components. Well, I don't have components because there's no angles. So I can go straight to sum of the forces in the y. That's ma equals up minus down. Now there's no acceleration up and down, so 0 equals normal minus 49, and I get my normal force is equal to 49. Okay? That's nice, right? Now, there's no friction, so I get to skip the friction step. So I can go to sum of the forces in the x. That's ma equals right minus left. Now, my mass is 5, my acceleration is 2, so it's 5 times 2 equals the force between box A. And there's nothing to the left, so that right there just tells me the force of box A is 10 newtons. So if we come back up here, look at the multiple choice part of this, and right there I see 10 newtons, so it's B. Okay? So that one wasn't too bad. Now, what if I want to go through and work that as if it had friction? How will that change this up? Well, the answer is it won't change it up a lot, but it will change the problem, okay? So let me get a piece of blank paper, and we're going to rework it as if it has friction. I'm just going to come in here, and mu kinetic will be 0.15. Okay, and I'm going to change F. I'm going to up F to 80 newtons. That way it does move and it does accelerate, and we're not really changing anything more than adding friction. Okay, I'm going to keep box A of 20 kilograms, and box B is still 5 kilograms. I still want the force between them, and we're pushing this way at 80 newtons. Okay. Oh, excuse me for a second. I'm still going to go through and combine the masses and find the acceleration with one mass. Okay? Sorry, I had a piece of artwork about to fall off the wall. So we're going to start off combining the mass to 25 kilograms. We have mg going down. We have the normal going up. Okay? We have the 80 kilograms going this way. 80 newtons going this way. And it is accelerating to the right. Now, what's different here, that is the same as the last one, but I have a force of friction going backwards this time because friction opposes motion. Alright, so going through our same routine, sum of the forces in the y, ma equals up minus down. Now it's not accelerating up and down, so we'll have 0 equals normal minus mg. And we know mg is 25 times 9.8, and we found that earlier on the previous problem. That was 245. So my normal is equal to 245. Now that's no different than what we did on this problem right here. What's going to be different now is I include the friction step. So friction equals mu times normal. So that is 0.15 because my coefficient kinetic friction is 0.15. My normal is 245. And get my calculator out. So I have 0.15 times 245. And that gives me 36.75. Okay, so now I have my friction force. Now I can go to sum of the forces in the x. It's ma equals right minus left. Okay. So on this one, my mass is the 25, so 25A equals to the right, I have 80 newtons. But this time to the left, I have 36.75 newtons. So that's going to change my acceleration a little bit. So it's 80 minus 36.75, and I'm going to divide that by 25, and I get 1.73 meters per second squared. So my acceleration dropped, even though my force went up, because friction's taken away so much. Alright, now I'm going to go over to the 5 kilogram box. Same thing, we're going to have mg going down. It's going to be 5 times 9.8, which is 49. We have the normal force going up. We have the force of box A pushing this way. We have friction opposing motion. And we have an acceleration this way of 1.73. So you can see, adding friction, I'm still doing the same basic process I did on this one over here. It's just my acceleration is no longer 2, it's 1.73. Okay? I'm going through the same thing. I'm going to do sum of the forces in the y. That 0 equals normal minus 49. Let me draw a line here separating. So my normal is equal to 49. And then we got the friction force. Friction is 0.15 times normal. So it's 0.15 times 49. So let's calculate that. 7.35. Now I can do sum of the forces in the x. This will be ma equals right minus left. Okay, there is an acceleration this way, and the mass is 5, so it's 5 times 1.73 equals to the right. I have the force of box A minus friction, which is 7.35. Okay, And 5 times 1.73 comes out to be 8.65. So 8.65 plus 7.35 is equal to the force between the boxes. So I'm going to add 7.35 to this, and I get the force between the boxes is 16 newtons. So adding friction to the problem doesn't really change it much. Hope you find it helpful.